Hi, this is section 4.2, the mean value theorem, MVT. So here let's just discuss the concept of the mean value theorem. First, when you look at we graph we sketch the graph of a polynomial function y equals f of x. And then we pick this point, we pick 2 points on the graph, we have a point P, which is a comma f of a, and then a point Q, which is b comma f of b. And then from these 2 points, we draw this line, straight line, which is called a secant line because it's crossing the graph of the function at 2 points. Then we go pick another point on the graph where we're going to graph this green tangent line, and that tangent line is going to be parallel to the secant line. So this green line is parallel to this red line, but the green line is only touching the graph at 1 point, so that's why we call it a tangent line. So it's touching the graph at the point c comma f of c. Because these 2 lines are parallel, they must have the same slope. So we know how to find the slope of the line that goes through 2 points. Basically, we do change in y over change in x. So the slope of this red line is going to be f of b minus f of a divided by b minus a. So what is then the slope of the green line? The slope of the green line is going to be the derivative of the function f of x evaluated at x equals c. So it's going to be f prime at c. The concept of the mean value theorem is that because the 2 lines are parallel and they have the same slope, then we will state that f of b minus f of a divided by b minus a is going to be equal to f prime at c. Basically, that's the mean value theorem. Now let's go to actually the statements. Okay, so the statement of mean value theorem is that first you're going to assume that the values of the function y equals f of x is continuous on the given interval a b. And then you're also going to assume that the function f of x is differentiable. So the derivative exists throughout this open interval a comma b. So if that's the case, then what the mean value theorem is saying is that there must exist a number c. That number is between the 2 boundaries a and b, such that f prime at c equals f of b minus f of a divided by b minus a. That's basically the mean value theorem. Now this f of b minus f of a divided by b minus a equals 2. F prime at c is comparing the 2 slopes of the 2 lines who are parallel, basically. And another version is that if you multiply this equation by b minus a, then you get this version of the mean value theorem. So let's apply this mean value theorem by an example. So they give us this function f of x equals to x squared minus 3x plus 1, and they also give us this closed interval 0, 2. And they want us to find, if possible, the point c that will satisfy the mean value theorem. Okay. That will satisfy the mean value theorem, meaning that will satisfy this f prime of c equals f of b minus f of a divided by b minus a. So as you can see, with respect to the interval, we know this is a is 0, b is 2 from the interval, and the function f of x is given to us. So based on the mean value theorem, we know we need to find f of b and then f of a. So since a is 0, to find f of a, we're going to plug in 0 for x into the function f of x. So when you plug in 0 for x, you get f of a is basically 1. And then to find f of b, you plug in x equals 2 into the function to get a 3. So then we go to the second part. We want to find f prime of x, the derivative, okay, of the function. Because the function is f of x equals 2x squared minus 3x plus 1, we take its derivative to get 4x minus 3. And then to find the left side, which is f prime at c, we're going to let x be c. So we're going to replace x by c to get f prime at c equals 4c minus 3. Now we get all the data. So this is the mean value theorem equation. So we know on the left side, we know f prime of c is 4c minus 3. And we got f of b to be 3, and f of a to be 1. And the b minus a means 2 minus 0. So when we do this calculation, we get a 2 over 2, which is 1. So we end up with 4c minus 3 equals 1. And then from this equation, we're going to solve it for c. So you add a 3 to both sides. You get 4c equals 4. You divide this equation by 4, you get a c equals 1. So this is c that we're looking for. Okay. So that c is somewhere between 0 and 2, where the two tangent line, one is going through these 2 points, 0, 1, and then 2, 3. The other one is the other tangent is going to be tangent to the curve at 1, 0. The two lines are parallel. So that's the values of c we're looking for. Any questions? Okay, thank you.